Hello students, today I will discuss about predicate logic or first order logic, or it is also called as first order predicate logic. In this lecture I will cover introduction, then syntax of first order logic, that is the basic elements, atomic sentence, complex sentence, quantifiers, and we will finish this lecture with an example. Introduction. As we know that to design an artificial intelligence system, we need to build a knowledge base so that the system could be able to take the decisions. For knowledge representation, we have some knowledge representation techniques. In the last lecture I have discussed about propositional logic. So there is another representation technique which is called as predicate logic or first order logic, or it is also called as first order predicate logic. So basically it is another way of knowledge representation in artificial intelligence. Predicate logic does not only assumes the world contains facts, as we have already seen in case of propositional logic that the sentences which we are representing using propositional logic, they are representing some kind of facts. So the sentences in case of propositional logic, they are classified as either true or false. So that was the limitation of using propositional logic. So in case of predicate logic, in this representation, we are not restricted to the fact that the sentence contains only facts. So it is a kind of extension of propositional logic. The predicate logic is an extension of propositional logic. First order logic, like natural language, that means as what the human beings are using the language, similarly the way of representation in case of first order logic, it is similar to that of natural language. And basically this representation assumes the world contains objects, relations, and functions. Objects are basically, they are the people, they are it can be houses, numbers, or it can be colors. Then these objects have some relations like red, round, prime, brother of, bigger than, parts of, and so on. And functions, that is the father of, best friend, one more than, plus. So the sentences that we are formulating using predicate logic, these sentences as objects, they are having relations and they are having some functions. It could be easily understood by using some example that we will discuss further. Now, syntaxes of first order logic, that means what are the basic elements? First is constants, that means name of a person or any constant like 2, 3, 4. Second is predicates like brother or some kind of relation like greater than. Then the functions like square root, less than, greater than, left leg of any person, left leg of any person. Then we could have variables like x, y, a, b. Then the sentences could have connectives as what we have already seen in case of propositional logic. We are having negation, if then we are having and, we are having or, we are having bidirectional statements. Then equality we are having, and one more additional thing is there that we are using in case of predicate logic, that is the quantifiers. that we will discuss in the coming slides. Then atomic statements. These are the most basic sentences of first order logic. These sentences are formed from predicate symbols followed by parentheses with sequence of terms. So basically whatever sentences that has been given to us, what we are doing, we are trying to identify some kind of predicate. For example, Aman and Harry are brothers. In this, the relation between these two persons is basically the relationship is the brothers. So brothers is basically it is a predicate, and Aman and Hari, these are terms. So we are representing this sentence using first order logic as brothers Aman, Hari. Then the next example is Bruno is a dog. So in this we are representing it as dog Bruno. Here you can think like that there is a class that is called as dog, and the class is having an object, and we are representing that object as Bruno. So you can also think like it's a kind of class object relationship, in that the object you are representing the bracket, and outside the bracket you are representing the class. The dog class and Bruno is the object of that class. Now complex sentences. Complex sentences are made from atomic sentences using logical connectives. That means if you are combining two or more atomic sentences by using logical connectives, then it becomes a complex sentence. Like for example, I am having a sentence, and I have represented that sentence using as, then not as. For the two sentences S1 and S2, S1 or S2, if S1 then S2, here it is bidirectional. So basically if you are using this representation scheme in this way, now the sentence has been converted from the atomic to the complex sentence. Now first order logic divides statements into two parts. First part is the subject and second is the predicate. So basically subject, it is the main part of the statement. So whatever the statement has been given to you, you find the subject in that statement, and you have to find the predicate. Predicate can be defined as a relation which binds two atoms in a statement. Like example, we are having a statement like x is an integer. In this statement the subject is x, and is an integer is basically it is a predicate. Now quantifiers. Quantifiers are the language elements which generates quantification. These are the symbols that permit to determine or identify the range and scope of a variable in a logic expression. So basically through the quantifiers we are defining the range and the scope of a variable. In predicate logic we are having two quantifiers. First is the universal quantifier. This is the representation sign of universal quantifier, and universal quantifier represents for all, everyone, everything. Second quantifier is the existential quantifier. It is represented by using sign, and existential quantifier can be used for some at least two cases. If x is a variable, then for all x is read as, that means universal quantifier x is read as for x, for each x, for every x. In universal quantifier we use implication sign. That means whenever you are using universal quantifier, the statements that you are formulating using universal quantifier, these statements require another logical connective, that is if then connective, which is also called as implication sign. Now if x is a variable, then existential quantifier will be represented as this, and it can be read as there exists a x for some x or for at least one x. Now whenever you are representing any sentence using existential quantifier, you use conjunction symbol that we will discuss later. Now here is one example, and it consists of so many statements, and we will try to represent all these statements using predicate logic. First statement is Marcus was a man. Second is Marcus was a Pompeian. Then all Pompeians were Romans. Caesar was a ruler. All Romans were either loyal to Caesar or hated him. Everyone is loyal to someone. People only try to assassinate rulers when they are not loyal to. Marcus tried to assassinate Caesar. Now what we are doing, we are representing all these statements by using predicate logic. Now first statement, Marcus was a man. So for example, if you are representing this statement by using predicate logic, you could think like there is a class which is the class name is man, and there was one object that is called as Marcus. So the way of representation is like this: Marcus bracket man bracket Marcus. Second statement is Marcus was a Pompeian. That means you could think like there was a class which is called as Pompeian, and there was a person Marcus who belongs to this class, Pompeian bracket Marcus. Now all Pompeians were Romans. In this we are having one quantifier, that is the universal quantifier, and I have already said in case of universal quantifier you have to use if then logical connective. So we are defining a variable for all x. Pompeian x tends to Roman x, because every Pompeian was a Roman. So you could think like there was a class which is called as Pompeian, and there is a class which is called as Roman, and Pompeian class tends to Roman. Next is Caesar was a ruler. So you could think like ruler is a class, and the Caesar was the object to that class. Now all Romans were either loyal to Caesar or hated him. Now in this we are having a universal quantifier that is called as all. For all x, Roman x tends to loyal to x Caesar or hate x comma Caesar. Now everyone is loyal to someone. For all x, there exists y such that loyal to x comma y. People only try to assassinate rulers they are not loyal to. So this way you could represent there were sentences using predicate logic. Initially you could find some difficulty, but as gradually you could able to visualize the way of representation. I will suggest that you should refer some books and try to formulate such kind of sentences using predicate logic. Marcus tried to assassinate Caesar. So in this we could see that there was a person Marcus, there was a person Caesar, and Marcus tried to assassinate Caesar. So try to assassinate could be a class, and this class objects Marcus and Caesar. Thank you.